Alright, this should be a relatively short video, just looking at the graphs of the quotient trig functions, tangent and cotangent. And the most important one is, of course, tangent. So let's just see. Let's consider the graph of tangent. And what do we know right now about tangent? Well, since tangent is sine x over cosine x, whenever the cosine of x is 0, the tangent will be undefined. Well, when is cosine 0? So let's see, cosine, here's y equals cosine x, and let's see, this was pi over 2, and then the next one was at 3 pi over 2, and if we go backward, we're at negative pi over 2, and then negative 3 pi over 2. So every time the number in front of pi over 2 is odd. So if we have a 3 times pi over 2, that was this one. If we have 1 times pi over 2, that's this one. If we have negative 1 times pi over 2, we get this value, and if we have negative 3 times pi over 2, we get negative 3 pi over 2. So how can we express an odd number times pi over 2? Well, the easiest way to express an odd number is 2 times n plus 1, where n is an integer. And remember that integers are like negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. So anytime we have, let's see, if n is 0, we have 2 times 0 plus 1, that's 1. If n is 1, we'll have 2 times 1 plus 1 is 3. If n is 2, we'll have 2 times 2 plus 1, that's 5. What if we go negative? What if n is negative 1? Then this will be negative 2 plus 1 is negative 1. If n is negative 2, we'll have negative 4 plus 1 is negative 3. We'll get all of the odd numbers. So every odd multiple of pi over 2, the tangent is undefined. And I'm going to write this as x cannot be 2n plus 1 times pi over 2 for n any integer. And remember this little symbol, this e means n, so if n is any integer, then the tangent is not defined, and what that means is that we'll have a vertical asymptote at every odd multiple of pi over 2. With tangent, however, we can get every single number on the range. And a really important thing about every trig function besides sine and cosine is that none of the other trig functions are sinusoidal. None of the others are repeating up and down. So there is no talk about amplitude with tangent, cotangent, secant, cosecant. One big difference of tangent as opposed to sine or cosine is that the period of the tangent is pi. And that's because all we have to do is go halfway around the unit circle to get repeating values. So in other words, tangent of x is positive in quadrant 1, it's negative in quadrant 2, but it goes right back to being positive in quadrant 3, negative in quadrant 4, and since those values are the same values, the only things that change are the plus and minus signs, then tangent repeats every pi units. So its period is pi. The symmetry is with respect to the origin, and that's because the tangent is odd. The important points for tangent, well, I know that tangent is sine over cosine. So when the sine is 0, we have a nice value. And there it is at 0, 0. Also, when the sine and the cosine are the same, then the tangent has a nice value. And that happens at pi over 4, negative pi over 4, 3 pi over 4. So let's see. At pi over 4, both the sine and the cosine are square root of 2 over 2. Well, if you take square root of 2 over 2 divided by square root of 2 over 2, you get 1. So at pi over 4, we get 1. At negative pi over 4, we get negative 1. And we're just going to use those 3 points. To graph the tangent. So the tangent is asymptotic to the line x equals pi over 2, x equals negative pi over 2. And let's see, we're going to repeat every pi. So if I go back pi units, I'll be at another x-intercept. If I go forward pi units, I'll have another x-intercept. And that means, let's see, another 1, get a negative 1, so we have this repeating graph of tangent. It's repeating, but it is not sinusoidal. Okay, well here's a pretty version of the tangent, and you can see, well, they don't show it very well here. At pi over 4, we get 1. At negative pi over 4, we get 1. And at every single multiple of pi, we get a 0, and that's because the sine is 0 at every multiple of pi. To graph the tangent, one thing, we are probably never going to move tangent vertically. So we're not even bothering with a plus d here. So if we have a function of the form f of x equals a times the tangent of bx minus c, then the first step is to identify a, b, and c. The period will be pi divided by b, not 2 pi divided by b like with sine and cosine, but just pi divided by b. And then there's something a little different with functions that have asymptotes. So we're going to take the standard tangent asymptotes at negative pi over 2 and pi over 2 and put the argument bx minus c in the middle. The argument is the name we give for the thing we're plugging in. So here, we're plugging in bx minus c. That's the argument. And we're going to place the argument in between negative pi over 2 and pi over 2 with inequalities, and we want to solve for x, which means we want to get x by itself in the middle of this inequality. What that will give you is the two asymptotes that are closest to the center, so two consecutive vertical asymptotes, and then we're going to find midway points. The point midway between these vertical asymptotes will be an x-intercept, and the point midway between the first asymptote and the x-intercept will be one of those pi/4 values, and the value to the right of the x-intercept will be another pi/4 type value. So let's look at this example. We want to sketch y equals 2 tangent of 3x. So here a is, let's see, a is 2, b is 3, and c is 0. The period is pi divided by b, which is pi/3. And now I'm going to take the whole argument, bx minus c, and put it in between the values negative pi/2 and pi/2 with inequalities. Well, our argument is just 3x, so we get negative pi/2 is less than, 3x is less than pi/2. These values to the left and right of x are going to give us the vertical asymptotes. To get x by itself in the middle, let's multiply everything by 1/3. Negative pi/2 times 1/3, 3x times 1/3, and pi/2 times 1/3. And we get on the left negative pi/6, and on the right pi/6, and in the middle x. That means that at negative pi/6, I'll have I'll have a vertical asymptote. So this is x equals negative pi/6, and at positive pi/6. We'll have a vertical asymptote. In the middle between them, we will always have an x-intercept. Well, it's easy to find that midway point between negative pi/6 and pi/6. That's just going to be 0. And the y-coordinate will also be 0 because it's an x-intercept. Now the important thing is to find the midway points between the left vertical asymptote and the intercept and the right vertical asymptote. To do that, we're going to add the x's and divide by 2. So I'm going to take negative pi/6, add 0, and divide by 2. Well, that's the same as in the inside. I can see that I'm just going to have negative pi/6. Dividing by 2 is exactly the same as multiplying by 1/2. And now it's easier. I get negative pi/12. So at the x value, negative pi/12, we're going to get the y value, negative a. So we've got negative pi/12, negative a, and since a was 2, we'll get negative pi/12, negative 2. Negative pi/12, comma, negative 2. To find the left value, the right value, we're going to take the center, the x-intercept, and the x value of the x-intercept. We're going to add to that the x value of the vertical asymptote on the left, on the right. And again, we're dividing by 2, which is the same as multiplying by 1/2, and we get positive pi/12. That means the next point is going to be positive pi/12, comma a, which is positive pi/12, comma 2. So here's pi/12, and here's 2. So we have pi/12, comma 2. The key thing I want you to know is that tangent is increasing. It goes uphill. It hits a nice value midway between its intercept and the vertical asymptote, midway between the intercept and the vertical asymptote. So these 3 points we're going to find, and the close vertical intercepts. Well, let's do one that's a little bit more fun. Let's graph y equals 1/4 tangent of 3x plus pi over 4. Here, a is 1/4, b is 3, and c, we're adding, so that means c is going to be negative pi over 4. The period is pi divided by b, and that's just going to be pi over 3. And we're taking the standard tangent vertical asymptotes at negative pi over 2 and pi over 2, and we're plopping down the argument in the middle. So this time we're going to put 3x plus pi over 4 in the middle between negative pi over 2 and pi over 2. To begin to get x alone, I need to subtract pi over 4 from every side. So we subtracted pi over 4 from the left. When we subtract it from the middle, we're just left with 3x, and we're subtracting pi over 4 from the right. In order to add, I need to multiply negative pi over 2 by 2 over 2 and positive pi over 2 by 2 over 2. So we get negative 2 pi over 4 minus another pi over 4. That's negative 3 pi over 4. And we still have a 3x in the middle. And then here we have 2 pi over 4 minus 1 pi over 4, and that leaves us 1 pi over 4. Now, we could divide by 3, but it is much easier with fractions to multiply by 1/3. Remember, dividing by 3 is the same as multiplying by 1/3. Anytime you have fractions, multiplying is loads easier. So I've got negative 3 pi over 4 is less than 3x is less than positive pi over 4. I'm going to multiply every side by 1/3. So I have 1/3 times negative 3 pi over 4 is less than 1/3 times 3x is less than 1/3 times pi over 4. And let's see what happens here. It looks like on the left, the 3's divide out, and we're just left with negative pi over 4. In the middle, the 3's divide out, and we're just left with x. And on the right, we have pi over 12. That means for this tangent function, the vertical asymptotes are at x equals negative pi over 4 and at x equals pi over 12. So these values to the left and right of x, when we have this inequality and x is alone, are the vertical asymptotes. So let's see, we've got a vertical asymptote at pi over 12. So this is x is equal to pi over 12. And we have another vertical asymptote at x equals negative pi over 4. And now what we need to do is find the point exactly in the middle between these. To find the midpoint, we add and divide by 2. So let's write that down because that's pretty important. To find the midpoint, between two x values, add the coordinates. Let's just put add the x values and divide by 2. And I'm going to remember that dividing by 2 is the same as multiplying by 1/2. And that's what we're going to do. We're going to multiply by 1/2. So let's see. We've got negative pi over 4 and pi over 12. So I've got negative pi over 4 plus pi over 12. The first step is to add the x's. And the answer is going to be multiplied by 1/2. That's this. Instead of dividing by 2, we're multiplying by 1/2. And I see that in order to get a common denominator, I need to multiply negative pi over 4 by 3 over 3. So now I get negative 3 pi over 12 plus pi over 12. And it's still all multiplied by 1/2. Negative 3 plus 1 is negative 2. We're still multiplying by 1/2. And now the 2's divide out. And we're just left with negative pi over 12. That means the x-intercept will be negative pi over 12 comma 0. So our center value is negative pi over 12 comma 0. And now we need to do that same thing 2 more times. We need to find the midpoint between x equals negative pi over 4 and negative pi over 12, and between negative pi over 12 and pi over 12. Okay, well that's not too bad. So we've got negative pi over 4 plus negative pi over 12, and we want to multiply that by 1/2. This is to find the midpoint, to find the value that is midway between negative pi over 12 and negative pi over 4. You add the x's and multiply by 1/2. Well, I see that I need to multiply negative pi over 4 by 3 over 3 to get a common denominator. That gives me negative 3 pi over 12, and then positive times a negative is negative, so minus pi over 12. That's negative 4 pi over 12 times 1/2. And let's go ahead and reduce this inside first. 4 goes into 4 once. 4 goes into 12 3 times. We're still multiplying by 1/2, and we get negative pi over 6. At negative pi over 6, this tangent curve will reach A. So we're going to have the point, negative A. We're going to have the point negative pi over 6, negative A. This is the point to the left of the intercept, so it's always negative A. And for us, A was 1/4. So this is going to be the point negative pi over 6 comma negative 1/4. Now we need to find the point midway between the x values of negative pi over 12 and positive pi over 12. That's actually pretty easy because they're opposites. We're still multiplying by 1/2, but negative pi over 12 plus positive pi over 12 is 0, and 0 times 1/2 is still 0. That means that the second nice point is going to be 0 comma A. Well, A for us was 1/4, so 0 comma 1/4. 0 comma 1/4. And then we're just going to sketch an increasing function that is asymptotic on the right to the upper part of the vertical asymptote, and on the left to the lower part. I usually put a half arrow if something is getting close to an asymptote, a full arrow if it's just going positive. Okay, great. I want y'all to pause this video, please, and do this one problem. Sketch the graph of y equals 3 times the tangent of 2x minus pi over 6. Okay, we're going to move on. The cotangent is very similar to the tangent, except the cotangent has cosine in the denominator. Pardon me, sine in the denominator. So we have cotangent is cosine x over sine x. That means whenever the sine is 0, cotangent is undefined. Well, sine is 0 at every multiple of pi. So here, x cannot be any multiple of pi. So this notation means x cannot be ... negative 3 pi, negative 2 pi, negative pi, 0, pi, 2 pi, 3 pi, ... So every single number times pi, every single integer number, so negative 1, negative 2, 1, 2, 3, and 0. Again, cotangent is not sinusoidal, so we don't talk about an amplitude. The period is pi, just like with tangent, and we're going to have a vertical asymptote at every multiple of pi. Cotangent is just like tangent. It is also odd, and that means it's symmetric with respect to the origin. Unlike tangent, the cotangent goes downhill. So first of all, for the cotangent, we have the inequality 0 is less than x is less than pi, where 0 is the left asymptote and pi is the right asymptote. So I'm going to go ahead and sketch x equals 0 and x equals pi. Midway between these vertical asymptotes, I will have an x-intercept. So the x-intercept is going to occur at 0 plus pi divided by 2. Let's see. 0 plus pi, and I'm going to multiply by 1/2. Dividing by 2 and multiplying by 1/2 are the same. Well, 0 plus pi is just pi, and pi times 1/2 is pi over 2. That means that pi over 2 will have a y value of 0. Just like tangent, the cotangent at pi over 4 and negative pi over 4 and 3 pi over 4 is nice. So the tangent, the cotangent of pi over 4 is 1, and the tangent of 3 pi over 4 is negative 1. So we get a function that's going downhill. It's very similar to the tangent, except it's going down. And here's a pretty picture of the cotangent. You can see that at every single multiple of pi, we have a vertical asymptote. At the midpoint between those vertical asymptotes, we have an x-intercept. And at every multiple of pi over 4 in lowest terms, we're going to get either 1 or negative 1. The steps for graphing cotangent are so similar to graphing tangent. The main difference is this inequality. We're going to put bx minus c between 0 and pi for cotangent, because these are the closest to the center vertical asymptotes, places where x is not defined. And we're going to solve this inequality so that x is by itself in the middle. Let's do that here. So we've got a equals 3, b equals 1/2, and c equals pi over 4. That means that the period is pi divided by 1/2. Well, dividing by 1/2 is the same as multiplying by 2, so this is just 2 pi. So the period is 2 pi, and we're going to solve the inequality. 0 is less than 1/2 x minus pi over 4 is less than pi. We always put the argument in between 0 and pi, and we're going to try to get x alone in the center. Well, the first step is adding pi over 4 to every side. On the left, we'll get pi over 4. In the center, we'll have 1/2 times x. And on the right, well, let's see, pi over 1 plus pi over 4. I need to multiply pi over 1 by 4 over 4. That gives me 4 pi over 4 plus another pi over 4. And that's 5 pi over 4. So 5 pi over 4. And now, what's the opposite of 1/2? Good, 2. So we're going to multiply every term by 2. On the left, we're going to get pi over 2. In the center, we get x. And on the right, we're going to get 5 pi over 2. That means my vertical asymptotes will be at x equals pi over 2 and x equals 5 pi over 2. So let's see. Here's pi over 2, and here's 5 pi over 2. Next, I want to find the point right in the middle between these values. That will give us the x-intercept. Let's see. So we've got pi over 2 plus 5 pi over 2. So we're going to add the x values and divide by 2 or multiply by 1/2. And let's see. We get 6 pi over 2. And we still have that times 1/2. And we can reduce this. So we get 3 pi times 1/2. And that's 3 pi over 2. So at 3 pi over 2, we'll have an x-intercept. Now we need to find the points exactly in the middle between pi over 2 and 3 pi over 2, and between 3 pi over 2 and 5 pi over 2. This time it's really easy, but let's go ahead and do the math. So we've got pi over 2 plus 3 pi over 2 times 1/2. We're finding the middle value between two x values, so we're going to add those, multiply by 1/2. So here we get 4 pi over 2, still times 1/2. 4 pi divided by 2 is 2 pi. We're still having this multiplying by 1/2, and 2 pi divided by 2 is pi. So that means at pi, we'll have a y-coordinate of a. And a for us was 3. So we'll have the point pi comma 3. Now let's find the midpoint between 3 pi over 2 and 5 pi over 2. And we have to multiply by 1/2 after we add the x's. Well, this gives us 8 pi over 2. We still have this times 1/2. 8 pi divided by 2 is 4 pi. And 4 pi divided by 2 is 2 pi. That means that at the x value of 2 pi, we're going to get a y value of negative a. So we're going to get the point 2 pi comma negative 3. And that gives us this nice graph. And I remember that it repeats everywhere. Well, thank you. That's the end of this short video. I hope you're doing great.